How's it going, everyone? My name is Griffin Furlong and I am a professional engineer. Today we are going to be diving into the world of grading. Now, this will be the first part of the series where we will be diving into a residential neighborhood. In other series, we will dive into commercial projects where we might have a warehouse with some sidewalk and a parking lot. I think before we dive in too deep, I will say that this is meant for beginners, people that have no idea on how to grade and, just people trying to understand what grading is. I think the first place where I want to start is just defining what grading is. So think of grading as the earthwork movement of the site. We as the engineer are responsible for dictating where earth is placed on the site for when we develop this project. So as you look around, you are noticing all of the different elevation changes, the slopes. All of those slopes and elevations have a purpose. Grading a site has a lot to do with where we want water to move. And what I mean by water is the stormwater of the site. So let's dive into some construction plans here. Here we have a residential neighborhood where you notice this dashed blue line. Well, that's the basin. And if you know anything about basins, a basin is where we are collecting water into a storage unit. The storage unit in this case is the pond. So as you can see, we have a road with some residential lots, and what we're saying here is that we want all of the water within this blue line to flow into the pond. Now, if we zoom in to the finer details of this, you'll notice that we have some curb inlets. These curb inlets are where we want water to get captured and go into the pond. Now, some of the basic details of a grading plan include curb inlet rim elevations, inverts of the pipe, which think of the invert as the flow line that is in the pipe. The invert of that pipe is the inner flow line. That is where water is going to be traveling. More details of a grading plan are spot elevations. What you also might find is the finished floor elevations. Again, this is for a residential lot, so we are establishing the finished floor elevation. That is the elevation right in that home where you are standing. But since this is for beginners, I don't want to dive too deep yet. I want to hit on a few very important topics. The one thing I tell young engineers is the only way to get better at grading is to, number one, observe the world around you. There are so many details that are around you each and every day. When you go to the grocery store, when you walk around your neighborhood, you can learn what the different slopes are. I remember when I was a young engineer and I first started out trying to learn grading, I had a really big problem because I couldn't visualize it. And it just so hit me that, just walking around my neighborhood, I was able to get a whole bunch of information. I actually took my phone out and would measure the different slopes. So I started understanding, what a steep slope was. What was steep? What wasn't steep? What was an average slope? Once you start building those foundational building blocks of, seeing something visual, you can then easily apply it to a set of plans. So that's definitely my number one golden tip for young engineers out there. Just study the world around you, get out your phone and understand the different slopes that are out there. Start measuring sidewalks, start measuring road slopes, measure a pond. Okay, the number two golden rule of grading is that you have to understand your toolbox. You have to understand what type of typical slopes that you're using. And if we're forgetting what slope is, which I hope no one's forgotten what slope is here, slope is the rise over run. We definitely need to go back to 8th grade geometry here and understand what slope is. Sometimes slope can be in percentages, or sometimes it can be a ratio. For instance, 4-to-1 or 3-to-1, 2-to-1, 6-to-1. Well, what do those mean? Let's examine it. So when we're saying that there is a slope of 4-to-1, we're saying that there are 4 horizontal feet per every vertical foot. So let me kind of draw that out here. So again, if any engineer tells you that they're grading at 4-to-1, the 4-to-1 is the slope. That means that for every 4 feet horizontal, you are going up 1 foot. For every 1 foot vertical, 4 foot horizontal. Now, same thing applies for 3-to-1. That means for every 1 foot vertical, I am going 3 foot horizontal. Okay, now that we've done a refresher on slopes, I want to show you what are some typical slopes that you might see in a residential neighborhood. So a typical road profile grade, which means, if I'm traveling across the road here, or traveling down this way, since technically that's how we're grading right now. Typical road profile grade going along this road will be anywhere between 0.32%, but the average for road profile grade lines will be 0.32 to around 2%. And again, that is 0.32%. Now, the typical side slopes for sidewalk or even road cross slope is typically 2%. You can go a little bit less, but we usually like to stay in the ballpark of 2% to allow water to move off of the sidewalk. You're also held by ADA standards for sidewalk for road cross slopes. You really don't want to get over 2%. And again, same thing for this road cross slope. You really want to be at a max of 2%. 2% is the average road cross slope. Now, I'm not grading a parking lot in this video, but I really like to keep my slopes anywhere between 1 to 8% in a parking lot. This is a residential neighborhood, and usually when we're grading these lots, there is a side yard slope right here. That's grading away from the finished floor building, and then again away from the finished floor building, and then grading down to where the road is. So where we're grading right here between this elevation of 77.09 to 77.79, we like to be anywhere between 1 to 3%, usually with 1% being the minimum. So just to kind of recap, again, one of the biggest things that you can learn from grading is observing the world around you. And then number 2, just understanding your typical slopes. Now you know what you're playing with. Now you're not going blind into a grading exercise. Once you know exactly what you can use, then we're cooking with fire. Now, there's one final thing that I haven't mentioned. So I think what's very, very important for grading is understanding your existing grade. So on this site, I have existing grade, and you can see these contours here. I have a contour elevation of 75. You have to have some sort of idea of your reference point that you're grading. How am I supposed to know to use 77s or 78s? What if my existing grade would have been at 50? That means I'm almost putting in 20 feet of fill here. You have to know your datum. You have to know what you are tying into, especially if you have wetlands on site, which we do here. We need to make sure that our lots are not grading into a wetland. And again, same goes for parking lots or commercial sites, which we won't dive into today, but you have to know what grade you are tying into if you're developing an entrance from a road. How are you supposed to know the different elevations that you're going to use if you don't even know your road tie-in? So I would say that is the absolute number one place where I start. I definitely always want to know the existing grade that I'm tying into and what the typical slopes I can use are. So I think to cap off this video, I'm going to kind of just walk through what is going on here with the grading. Usually when we design residential neighborhoods, these road low points, which the road low points will always be where our curb inlets are, because again, we're trying to capture the water and send it into the pond. Usually these road low points are governed by the pond's design high water. And we won't be diving into, what this means, but think of this pond. When it fills up, it wants to reach a certain level. Well, we really don't want the streets to flood, so we will design these low points to make sure that they don't flood. So I always start with the design high of the pond. In this case, this design high for the 25 year is 76.45. So during a design storm of a 25-year storm, it's getting up to that elevation. Now, when I go look at low points for these inlets, I'm seeing that the edge of pavement grade that we set was 76.45. So we are setting that low point of the edge of pavement right at the design 25. We're ensuring that the design 25 of that storm is not flooding the streets. In this case, we set the low point to 76.45. Now let's do a quick measurement to see the width of this lane. So the width of the lane, I'm gonna call that 12 feet. Bluebeam must be acting up, but that's 12 feet. So we know that the road slope is typically 2%. So I can take that 76.45 and work up 2%. Now, the really smart engineers out there can do some quick math for you, but I'm just going to, calculate it out here. 12 times 0.02, because that's 2%, we need to go up 0.24. And again, we need to go up 0.24 from that elevation. So again, that's 76.45 plus 4 equals 0.69. And obviously on our plans, we're a hundredth less, which probably makes it out to still about 1.99%. That is absolutely fine. Another elevation that I want to check is this road profile grade line. I have to make sure that water gets from this intersection all the way to this low point here. Let's double check what the slope is here. And I love the blue beam tools here. I'm gonna double click there. Got about 322 feet going up 0.32%. But like I said, you can vary. You can vary this. You can go 0.32, you can even do 0.35. For this sort of situation, really never go higher than 1%. You know, for the experienced engineers out there, once the algebraic difference between the road profile grades 1 to 1.3%, you need to throw a vertical curve on there. But that'll be a whole nother topic of discussion. Right here, we're going to work this grade from the low point all the way up to the high point, and let's see what we get. So 323 times 0.0032 gives us 1.03 feet that we're going up. So if we do the 76 point and added 1.03, 77.71. So we just finished grading the profile grade line from that low point up to the intersection high point. That's all I have for today. I hope you guys learned something new about grading. We will dive into other forms of grading like commercial sites and other residential sites. Let this serve as an introductory lesson to the other forms of grading that we're going to do. If you guys want to cover any other topics, feel free to comment below my video, and don't forget to hit the subscribe button. Thanks everyone, and have a good day.